Friends, today we will learn about network collector in Cisco Packet Tracer. How we can create a network collector or a network flow collector, which will show you the network flow, traffic flow, and how the packets are going and the traffic is going on the network. So let's start. So I am using here two routers. First one this and one more router, and I'm using one switch, one end device as a laptop or desktop, or one switch. Okay, so let's just create connect it with the proper cable. So we know that for different device we use straight through cable. So for PC to switch we will use straight through cable. So I'm using here fast Ethernet 1, and here is also the same cable I'll use, and for router to router we will use crossover cable. Okay, so for going forward, to configure network flow collector, we'll have to advertise network first. So we have to configure the IP address for these interface on each device except this switch. So I will use here the IP 192.168.1.1, and here I'll use 192.168.1.2, and in this interface I'll use 192.168.2.1, and you can use as per your choice. And 192 for end device 168.1 sorry 2.2, because this is the same network for this. And for each IP I'll use subnet 24 of class C, subnet 24. So let us configure it one by one. So I'm using first router number 3 on CLI mode, enable conf50 interface. We know that the interface is gig 0 by 0. So interface gig 0 by 0, assign IP address, IP address 192.168.1.1, and with subnet mask 255.255.255.0, and no shut to bring the interface up. Okay, and we will configure the IP address for this second router also. Make it no, enable config interface first gigabit 0 by 1, IP address 192.168.1.2, and subnet mask 255.255.255.0, and make it no shit. So you can see the interface comes up you can see the green light blinking. And for interface, gig 0 by 0 and IP address 192.168.1 and same subnet mask IP no shut. So you can see this interface also brings up, and I'll also assign the IP for end device in this desktop. The IP is this 192.168.2.2. So 192.168.2.2 and subnet mask 255.255.255.t0, and also assign the default gateway of this interface address. So this is 2.1. So 192.168.2.1 default gateway. Okay. So we have assigned the IP for each device. Now we have the next steps to configure routing protocol so that the traffic can go from each device to one device to another device. Because if I try to send the packet from router 3 to device this PC, so you can see the traffic is going to fail, and packet is going to fail. So we have to configure routing protocol. So I'll use routing protocol as OSPF. The OSPF routing protocol config t router OSPF. I'm using OSPF 1, and network. We'll use network as if you don't know how to configure OSPF, so please check my other video. You can find how to configure OSPF from beginning. So I'm using the network this and this the same network, so 1.0 will be the same network for this 192.168.1.0. and here we configure the wildcard mask. So for 24, wildcard mask will be 0.0.0.255, or area I am using here 0. Okay, and here write name so that the configuration can be shaped. Okay, and also configure the routing protocol, the second router config t interface gig 0, no sorry, router OSPF 1 network and 192.168. for this here are two networks, as the first one is 2.0 and second one is 1.0. so we have to configure both the networks in this router. So 1.0 and same wildcard mask 255, and area is also I'm using same 0, and the next network will be 2.0. so I'm just yeah, okay, and write name so that configuration could be saved. Now we can send the packet. Let's see if the packet is failed and or is passes through one device to another device. So this, now the network goes fail, packet goes fail. Now again I'm trying, and now you can see this is the successful packet forward successful, and this successful also. Okay, so and you can use check by this command prompt. I'm using ping. I'm pinging the IP of this device. So 192.168.1.0 1.1 1.1. So you can see the reply coming from the destination device. So now routing protocol is configured. The next step is how to configure network collector, this net flow collector. So here you can see there is no data. If I make it on, so after making it on, still there is no data here. So we have to configure the some few command on the router where you need to monitor. So suppose I am using this router and going to configure network NetFlow collector configuration so that we can monitor it from this device. Okay, so the configuration for the NetFlow collector is config t IP flow export destination IP, this IP. So 192.168.2.2, and you can use the shift key with the question mark, so you can find it. It is asking for UDP SCTP port number. So UDP SCTP port number you can assign any from 1 to 65535. So I'm using here randomly 9996. Okay, IP flow export version number you can also use a shift with question mark, and here it is available only 9, so version 9. Okay, so this configuration done. Now we have to configure the some configuration on interface also. So for coming interface and outgoing interface, we use ingress and egress command. So for coming interface is gig 0 by 0. So interface gig 0 by 0 and IP flow question mark. So ingress, we have to enable inbound NetFlow for, so ingress. Okay, and the next interface, this outgoing interface gig 0 by 1 and IP flow egress. Okay, so configuration is done. Now it is done to check the network traffic. So we have to first ping the IP from one device to another device so that it can be captured on NetFlow collector. So I have pinged 4 packets. Now let's see if it is monitored on the NetFlow collector or not. So here you can see there is no data, but you can see the data just come. So here are 2 types of data. First is the blue mark. So blue mark, if I click here, so you can see the IPv4 source address 192.168.2.2. so we have pinged the IP from this address, so it is giving the IP of the same device from which we have pinged. In destination address, where which IP we have pinged. So the ping IP was 192.168.1.1 that we have pinged from here to this device. So you can see this monitor and has an interface input interface, which one was, so that one was 0 by 0, so it was also giving here, and IP protocol 1 because we use the router OSPF protocol 1, so here I'm giving the IP 1, and source mask 2424 counter byte 50. So lot of information you can find here. And counter packets, how many packets we have sent to destination. So we have sent 4 packets. So, and if we check the second half, so second half is also giving the some information, and that seems similar information. So that's the uh, things we can monitor it from here. So that's it in this video. Hope you will enjoy, you have enjoyed this video. Please like and share and subscribe this channel, and comment in the comment section if you have any query and doubt. So we will give you our best. Thank you so much.